We got one more thing to learn this week, and then we're going to spend the rest of the period in review. Okay? Because there's a lot. We're not done yet. We will split this chapter and just test over half of it. That might be the end of next week. I don't know. I need to figure that out soon. But it won't be any earlier than the end of next week. I know that for sure. Okay? So here we go. This lesson today, very simple. It's about doing things with functions. So I've just listed some random functions over here, not special ones, just random functions. And the first thing I want you to do is add f and g together. Okay, now that's easy. F plus g would be 3x plus 1 plus 2x squared minus 3. That's it. It's that simple. Now, I would probably want to collect like terms and clean it up a little bit. But when it says add the functions, that's what you do. You just add them. So I would probably write that as 2x squared plus 3x minus 2. Is that okay with everybody? Okay, in a minute we're going to get our note sheets out, but right now we're just doing a quick overview, okay? Now, what do you think this means? We're just going to subtract them. So we'll take G, just pay attention for a minute, guys. We're going to get our note sheets out in a minute, and subtract X, or H. Now with subtraction, be careful. I have to subtract the whole thing, so I have it in parentheses. So that'll be 2x squared minus 4x minus 5 if I collect like terms. This is a times. So what do you think that means? Multiply G times H. And because they are both binomials, that means I'm going to have to FOIL. So 8x cubed plus 4x squared minus 12x minus 6 is my answer. And the last one there means divide. So we'll simply have 3x plus 1 divided by 4x plus 2. Everybody okay with that? All right, let's get our note sheets out. And let's see if you can do, maybe you and your partner, we are on the back of page 10. I know we have some gaps to fill in, and we will do that. But could you do A through E for me? 1.4, number 1, A through E. Come on. Get off the iPad, man.
I'll just take this here.
Okay. Well, right now we're in math, and that's the most important thing. So on the back of page 10, 1.4, can you do A through E? It's exactly what we just talked about, but different functions. I'll write down what I think the answers are. Can you do it? So, really, there's no terms in the last year, something like that.
It won't be. It's going to be fired up. All right. No, I use 2%.
Moses and Zach, You got these done?
Yep.
You do?
You said go to E, right?
Yeah, A through E. Yeah, did you check them with me? All right, let's talk about A. Anybody have a question where A came from? Guys, I do not want to spend a lot of time on this. Ashley?
Would you accept it if it was x plus 2 plus x?
Yes, Ashley says, does the order matter? And let's talk about descending order. Does that term sound familiar to you? Normally, when we write our answer, it should be in descending order. I'm not going to mark it wrong, Ashley, but that's just the kind of the best way to do it. All right, any other questions about A? How about B? That was a little tricky one. I didn't talk about it ahead of time. Did you figure out what you were supposed to do? Simply times everything in F by 2. Everybody okay with that? Mahoney, are you all right today? Okay. You look bored out of your mind, and I know you can't be bored in math class. C. Anybody have a question about that one? Watch your SIGNs, guys. Remember, you're subtracting the whole quantity of H. D. Anybody have any question about D?
Where did you get x cubed?
When we multiply F times G, we're taking x squared times x plus 2. And when you take x squared times x, you get x cubed, right? And E. Any question about E?
I thought you couldn't have a square in the denominator. Or not
You
just,
can't have a square root
oh, so yeah.
in the denominator. Okay, everybody good on that? All right, now look, F says, what's the domain? F talks about domain. All right, so let's look at A. What's the domain? Oh my gosh, I'm about ready to have a fit. All real numbers, thank you. What are our rules? No fraction, no radical, no problem. Domain is all real numbers. How about this one? All reals, all reals, all reals. Oops. X can't equal 0. Very, very good. Now, G. Does anybody know how to say this problem? How to read it out loud? Does anybody know how to say that? Jake?
F of G times 2.
Almost. You had it almost to the very, very end.
Oh, that's right.
F of G of 2.
Of 2.
Yes. So we say F of G of 2. Now, you may have, I don't know, depending on your book and your teacher last year, you may have seen this written like this, with a little open circle there. Now, that is not a time sign, that's an open circle, and it means F of G of 2. These two notations mean the same thing. So if it's written this way and you don't like it, you can write it this way, and vice versa. F of G of 2. Now when you are evaluating this, you start right here. Start with the letter closest to the number and figure out what that is. What is G of 2? Well, G of 2 would be 4. Did I copy my problem right? I want to make sure I did. Yeah. G of 2 is 4. Is everybody okay with that? How do we find G of 2? plug into G, and I got 4. So this right here is 4. So what does the problem say now? Find f of 4. So now I'm going to take the answer that I just got, and I'm going to plug it into f, and I will get 6. And that's your final answer. Does anybody know what we call this kind of problem? It's got a name. Composition. It's called composition of functions. We're making a big function, doing lots of things one step at a time with little functions. Look at H. What's the answer to H? 6. It's the same problem, isn't it, Zach? Just written differently. Now, G of f of 2. Now this is different. This says G of f of 2. So where do I start? F of 2. And f of 2 is 4. Then I take that 4, f of 2, this is like 4 now. I take that 4 and put it into G.
Yep.
And G of 4 would be 16. And that's your answer. So, gang, does it make a difference if I do f of G or G of f? Does that make a difference? Yes, right? You got to pay attention. And where do we always start? With the letter closest to the number. Okay? All right, so let's look at the next one. H of f of negative 1. Okay, step 1. Jennifer, step 1. Can you tell me what I do first? I do. And when I put negative 1 into the f, Jennifer, what do I come out with? Positive 1. Very good. Now, Olivia, I'm going to take that 1 that I just got right here. This equals 1. And what am I going to do with that 1? Put it into H. I'm going to find H of 1. And what do I get when I put 1 into my H? Perfect. And that's the answer to the question. Now look at K. Oh my gosh. What is going on there? F of G of H of 1. F of G of H of 1. Okay. Jack, where do I start?
H of 1.
I find H of 1. And Olivia just did that for us. H of 1 is 3. Would everybody agree with that? Julian, what are you doing on your iPad? Now, this right here was 3. Now, Jordan, what do you think I'm going to do with that 3? I'm going to plug it into G. So what is G of 3? 9. And then Moses, what am I going to do with that 9? Plug it into F. And F of 9 would be 11. Is that okay with everybody? Nathaniel, what's on your iPad?
Email.
Huh?
Email.
Okay, we'll take it off. Put it away. We don't need to be checking our email now. and L. What's different about problem L, you guys? There's no number to kind of get us started. This is f of g of x. Okay? So we gotta find f of g of x. What's g of x? X squared. So we're going to find f of x squared. Look, it says find f of g of x. But we are told that g of x is just x squared. So we're going to find f of x squared. Now, when I find f of anything, what do? Take out the x and put in the anything, right? So I'm finding f of x squared. So I'm going to take out the x, and in its place, I'm going to put x squared. So f of x squared would be x squared plus 2. And that's your final answer. Now there's another one of those on the next page, so let's try it. Again, there's no number to start with. So in a way, this is easier. What's f of x? You already know what that is. What's f of x? F of x is just x plus 2. So we're finding h of x plus 2. F of x is x plus 2. Now your h function is negative 2x plus 5. But we're going to take out that x and replace it with x plus 2. So we have negative 2x plus 2 plus 5. Instead of the x, we're going to plug in whatever we're supposed to, which is x plus 2. So our answer, final answer, ends up being negative 2x plus 1 when you collect like terms. Lexi's holding her head. Yes, it's mind-boggling for sure. All right. Now, what we need to do at this moment, we have one more section. We'll talk about that on Monday. But what we need to do right now is go back through our packet and fill in anything that we didn't get to. So what's still blank? Tell me which page, which problem number, whatever is still blank. We need to do it. We did it all? We did it all. We are amazing human beings. Okay. Then we're going to do some quick review, and I will give you a little time to work on your homework. But I want to do 2 things for review. One of them is I want to do another piecewise function. Those are the functions that we graph in pieces. So take out a piece of paper. Quit complaining. I know you love it. Take out a piece of paper. Now, for this problem, notice it's graphed in pieces. And kind of the breaking point for the pieces is where x equals 1. Now, that's not an asymptote. I'm drawing it like an asymptote. But that's just my visual reminder that that's where the pieces are. We're either to the right of that line or to the left of that line. We're either bigger than 1 or less than 1. Okay? Now, let's look at the top line, forget everything else and just look at the top line. It says y equals x plus 2. What shape is that? It's a line. Isn't that your identity, kids? So we're going to pick it up 2. So if I pick my identity up 2, I get this line right here. That's supposed to be a straight line. I'm not very good. I get that line. But remember, this graph is in pieces.
Does it matter where, like, it touches on the x-axis?
Well, it should be at -2
Okay.
because that would make a 0 there. Get it as close as you can.
Alright, so,
If it helps you to plot some points, you can do that. You know, kind of think of a T-chart if you want to, if that helps you. Okay. Which piece do we want? Do we want to be to the right or do we want to be to the left of this line? Because only one piece counts. What does that say? Right, right? That says to the right. So I'm going to put an open dot right there and I count this. This I want to keep. Everything else is going to get erased. So I guess, Zach, it doesn't even really matter because I'm erasing all that, all right.
yeah.
Now what does that middle piece look like? Y equals x squared. What shape is that? That's a parabola. So that's going to look like this. Beautiful parabola. But I don't want the whole thing. I want either the part of it to the right or to the left. Now, I don't know if I mentioned this the other day or not. You're never going to have 2 pieces on the right or 2 pieces on the left. There's always 1 piece on the right and 1 piece on the left. So since you already counted the right piece of this, I'm going to be counting the left piece of the parabola. So I'm going to put an open dot right there, and I'm going to erase all of this.
So is all this gonna come back to
the line. Yep, it's always going to come back to the line. The question was, is it going to come back to the line? And the answer is yes, it is. Now that last one is tricky. Let's look at what it says. Y equals 5, x equals 1. Wait a minute. X is 1, y is 5. What is that? How do I graph that? That's just a point. It's the point 1, 5. It says let x be 1 and y will be 5. That's just a point, 1, 5. Okay, and you're done. You're all done. Good work. Yes, Trey?
Why do you have the x plus 2 line at 3?
Well, remember that it's actually on the y, this is my y-axis, and it's actually here. Remember, I had that whole line graph, but because of where it's split, I had to start it over here, because that's where it tells me to split, where x is 1. Not where x is 0, where x is 1. All right, anybody have a question about that? We good? Okay. And then the last thing I wanted to just kind of touch base on was this problem. And I want you to give me the vertical asymptote, the horizontal asymptote, and the holes. Okay. Now, before we jump in, before we give any answers, let's stop for a second. should we do something to get this ball rolling? What do you think we should do? Let's factor. Let's factor. So what can I do on the top? I can take out a 2, right? Let's take a 2 out first. Oh, shooty tooty. I need this to be an 8. Sorry, fix that. Make that an 8. Got it? Okay, so we're going to take out a 2. Now, does the top and bottom, or do the top and bottom factor anymore? Is there any factoring I can do on the top? X squared minus 4 factors as x minus 2, x plus 2, in either order, that doesn't matter. And how about the bottom? X minus 2 minus 1. Now our little hearts are pitter-pattering because we can cancel. And the moment you cancel, you know you're going to have a hole. Holes only happen one way. They happen when you cancel. No cancel, no hole. The hole is a point. Whatever you canceled will give you your x. We canceled out x minus 2, so we're going to have a hole at 2. Remember, it's always the opposite. And our new problem is this. This is what we ultimately end up with when we take out the factor that cancels. So I know that x is 2, because that's what canceled out. How do I find my y? I plug it in. And when I plug in 2, I'm plugging in my x, I have 2 times 4 over 1. I got 8. Put in 2. Is that okay with everybody? Let's talk about that one more time. Where do holes come from? Where you cancel. If you had a problem and you canceled out x plus 3, where would your hole be? At negative 3. Now, take a look at what's left. Do you have any vertical asymptotes? Look at what's left here. Any vertical asymptotes? Yep. Where is it? X equals 1. Do you have a horizontal asymptote? Yes. It is y equals 2. That's a 2x. I haven't factored, but it's still a 2x over x. All right, what do you think? Ready for a break?
Yeah.
Please, don't make me do that class any longer. All right. I do not know how far you have gotten on your homework, but you still have this extra practice sheet that was yesterday's homework. And you still, well, it's this week's homework, it's all mixed up. And now you have a few problems to do in 1.4. So get on Schoology. You have the entire week's worth of work. I reserve the right to check any or all of it on Monday.